Good morning, students. This is Murthy, sir. Today, you will learn an interesting topic in organic chemistry, the nomenclature of organic compounds. The purpose of the IUPAC system of nomenclature is to establish an international standard of naming compounds to facilitate communication. The goal of the system is to give each structure a unique and unambiguous name and to correlate each name with a unique and unambiguous structure. IUPAC stands for International Union of Pure and Applied Chemistry. In order to avoid long and tedious names in normal communication, the official recommendations for naming IUPAC are not always followed in practice, except when a compound has to be given an unambiguous and absolute definition. Sometimes IUPAC names may be simpler than older names, as with ethanol rather than ethyl alcohol. This table shows the homologous series of alkanes. CH4 methane, C2H6 ethane, C3H8 propane, C4H10 butane, C5H12 pentane, C6H14 hexane, C7H16 heptane, C8H18 octane, C9H20 nonane, C1022 decane. Alkyl groups are formed by removing one proton from the respective alkanes. Methane, methyl, ethane, ethyl, propane, propyl, and so on. Now let us learn about the prefix and suffix names of some functional groups. For alkenes, suffix name is -ene. For alkynes, suffix name is -ine. For halides, the prefix name is -halo. For alcohols, suffix name is -ol and prefix name is hydroxy. For aldehydes, suffix name is -al and prefix name is -oxo. For ketones, suffix name is -on and prefix name is -oxo. For nitriles, suffix name is nitrile and prefix name is cyno. For ethers, prefix name is alkoxy. For carboxylic acids, suffix name is oic acid and prefix name is carboxy. For esters, suffix name is oiate. For amines, suffix name is amine and prefix name is amino. Now, let us learn about the rules of IUPAC system of nomenclature. Here is a simple list of rules to follow. Some examples are given at the end of the list. The first rule is identify the longest carbon chain. This chain is called the parent chain. Rule 2. Identify all of the substituents, groups appending from the parent chain. Rule 3. Number the carbons of the parent chain from the end that gives the substituents the lowest numbers. When comparing a series of numbers, the series that is the lowest is the one which contains the lowest number at the occasion of the first difference. If two or more side chains are in equivalent positions, assign the lowest number to the one which will come first in the name. Rule 4. If the same substituent occurs more than once, the location of each point on which the substituent occurs is given. In addition, the number of times the substituent group occurs is indicated by a prefix, di, tri, tetra, etc. Rule 5. If there are two or more different substituents, they are listed in alphabetical order using the base name. We must ignore the prefixes. The only prefix which is used when putting the substituents in alphabetical order is iso, as in isopropyl or isobutyl. The prefixes secondary and tertiary are not used in determining alphabetical order except when compared with each other. Rule 6. If chains of equal length are competing for selection as the parent chain, then the choice goes in series to A, the chain which has the greatest number of side chains, the chain whose substituents have the lowest numbers, the chain having the greatest number of carbon atoms in the smaller side chain, the chain having the least branched side chains. Rule 7. A cyclic hydrocarbon is designated by the prefix cyclo, which appears directly in front of the base name. In summary, the name of the compound is written out with the substituents in alphabetical order followed by the base name. Commas are used between numbers and dashes are used between letters and numbers. There are no spaces in the name. Now let us learn some practical examples of nomenclature. These are straight chain hydrocarbons, N-butane and N-pentane. These are branched chain hydrocarbons, neopentane and neohexane. This is a branched chain alkane, 2-methylbutane. This is a branched chain alkane, 2,2,4-trimethylpentane. These are propane and alkane, propene and alkene, propyne and alkyne. Alkanes contain a single bond. Alkenes contain a double bond. Alkynes contain a triple bond. These are branched chain alkanes, 3-chloro-2-methylpentane, 2-bromo-3-methylbutane. These are cyclic hydrocarbons, cyclopropane, cyclobutane, cyclopentane and cyclohexane. Here you can observe two ways of structural representation of cyclic hydrocarbons. This is 2,7-dimethyl 6-propyl nonane. Here parent alkane is nonane, which contains 9 carbon atoms. Now let us see some examples of alkenes and alkynes. Pent-4-ene-1-ol, Pent-1-ene, But-2-ine-1-amine, Pent-2-ine. Now let us learn about the cleansing action of soap. Most of the dirt is oily in nature and oil does not dissolve in water. The molecule of soap constitutes sodium or potassium salts of long chain carboxylic acids. In the case of soaps, the carbon chain dissolves in oil and the ionic end dissolves in water. This is the structure of soap molecule. You can see here hydrophilic group and hydrophobic group, ionic end and hydrocarbon end. A soap molecule consists of a polar ionic hydrophilic end, which is shown in blue color in the structure above, and a non-polar hydrophobic end, which is the hydrocarbon chain shown in red above. The wheel-like structure formed by the circle of soap molecules around the dirt or oil droplet is called a mishal. Soap molecules dislodge dirt, oil, and grease particles, and the disease-causing germs they carry from your hands one mishal at a time. This is the structure of mishal. A mishal is a spherical aggregate of soap molecules.